Okay, hello everybody. I'm here to talk to you about a new idea that popped up a few years back, and we've been working extensively across the world. It's very simple, basically. We want to transpose what is happening in the digital internet that you all know about, your mobile phone, your web, and so on, and translate that to real objects. So we're going to talk about logistics and try to make it more efficient, more sustainable, and moving toward interconnected logistics. Logistics has become the backbone of our life. We don't really look at it, but it's all around us. Our lifestyle, when we see this nice meal over there, it's something that would have been king's meals many years back, but now we take it as granted. We can find it in all superstores, and we can have it in many restaurants. Also, when we go on e-commerce and we buy stuff that is not virtual, that is physical, and then we check and they say it's going to be free shipping in a few days, this is all sustained by logistics in the back. And the growth of world trade that we've seen in the recent years has been very much sustained by logistics. And one small element that we see all around is the container. Okay, the ships have been changed, the ports have been changed, multimodal work has been changed. So it has completely transformed world trade. Yet, even though it looks good at the surface, we have to face arch facts. In fact, we claim that the way physical objects are moved, stored, realized, supplied, and used across the world has become inefficient and unsustainable from an economic, environmental, and social perspectives. So in fact, in some ways, it's victim of its success. If we look at the little graph that we see on the screen, it shows that basically we have been creating more and more greenhouse gas emission through logistics and transportation, while for example, in this stage, this is in France, like the goal from the European Union is way, way lower than what we're doing now. And right now we've been increasing steadily, while we should be reducing by an order of magnitude. We're not going to get there by doing just marginal epsilon type of changes. So, but this kind of big numbers is fine for beginning a talk, but it does not appeal to you in real life. So what we've put is a series of symptoms that explain what we're talking in ways that will more make sense to most people. So if you go and see trucks, okay, on the highway, and you think they're full, in fact, most of the time they're not full. Even though they appear full, in fact, many times they're shipping air and packaging. The average rate of fullness is about 60% when they get out of the distribution center or the factory. So 60% in terms of weight or volume. So, and as the roads keep on going, there's less and less filling. So we've got a lot of air, and also we've got so much packaging. You open the boxes, you see all kind of stuff in there, and finally you've got a small objects, and you had a box like that to move it. So that's a very big problem. And then when your truck reaches destination, okay, it's empty, now it wants to go back home. Getting back home, it doesn't want to go by itself empty. So it does travel to get some stuff and then finally get home. There's about 25% of travel that is spent empty, completely empty. Now, if I go on a human perspective, I'm using again the trucks as example. We've got the truck drivers. In fact, comically, they become like the modern cowboys, okay? They're sitting on those big horses, okay? They just go and drive for days and days and days before they're going to come back here. So, for example, somebody will ship something to Portugal, so it goes all the way to Portugal, and sometimes it's going to come back to Romania. So, in fact, they have health problems, family issues, social life is affected, turnaround time in the business can be up to 100% per year of changing personnel. If I look at the products, even though we've talked about just-in-time manufacturing for decades now, well, most products, their entire life is spent sitting, waiting for somebody to use it, okay? So they're stored where they're not needed, and they're not right exactly where we want them as needed. So that's for example, you'll have like 2 months of stock, but when I ask for this specific product, you don't have it, okay? So, or it's somewhere like 1,000 kilometers from now. And if I look at the facilities level, you look at the distribution centers, the warehouses, the factories, then we see they're poorly used or badly used. Poorly used means that they're going to be used heavily in a few weeks and a few months in the year, but afterward, they're not going to be used much. Or they're going to be badly used, because this means that we've got the machines there, so let's go and do stuff there. But we're doing stuff there that's going to be used thousands of kilometers away from here, so creating a lot of movement that's not necessary. And if that was not enough, so many products are never sold, never used. Clothing, food, and so on, that will never, ever be used. And on the screen, I'm showing a disaffected airport that is filled with new cars that are rusting. Okay? They're never going to be sold. So, and obviously, if we go to a more disaster-type area or crisis area, famine-type area, the products have trouble reaching those who need them very much. There are many more examples of that styles, okay? We've got products crisscrossing the world unnecessarily. City logistics has become a nightmare. The bigger the city, the older the city, the worse is the problem. Getting products in the city, through the city, out of the city is a big deal. Multimodal transport would be very nicely, because trains are much more economical and per ton, they emit much less pollution, much less gas emission, greenhouse gas emission than your truck. But this multimodal is very marginal, because right now it's not efficient. Automation is hard to justify. Technology is hard to get in there. We've got supply chains that are unsecure and fragile. We've concentrated so much of the production and so much of the distribution in centralized facilities that would happen anything to those single facilities would be in trouble. Same goes with the roads and routes that we're using. So overall, we've got innovation that is strangled. So I've drawn a pretty bad picture of what's happening to logistics all across the world. Now, having said that, then what we tried is come up with solutions. So there are many solutions, like going to green car, electricity, and all that. We came at it from a different perspective. What we said is, the solution we're going to talk about is transforming the way we do logistics, supply chain, transportation across the world, and think it the same way or a similar way to what we've been doing with information technology. Transform it from the current system that's dedicated, that is proprietary, very disconnected, and go to a very interconnected system like the internet, and that's why we call it the physical internet. I'm going to get more on that. But more important is that we're using this metaphor as inspiration. We're not trying to copy the internet, digital internet, because obviously every time I'm moving an object, somebody has to take it, move it. It takes time, there are costs involved. It's not like data that click, it's gone to Beijing. So it's not like that. So we have to change to adapt consequently. So, and we're not trying to do a physical internet just for fun. It's because we are going to face a hard wall, and we need solutions that are going to help us go in that direction. So in 2006, we started this notion of physical internet. So for 10 seconds, okay, let me state a more formal definition, and then I'll try to present it more easily for you guys. The physical internet is an open global logistics systems founded on physical, digital, and operational interconnectivity through encapsulation, interfaces, and protocol. That's a dull type of definition, okay? It's a kind of definition that if you ask somebody what is the internet, a technical definition, that's a style that you'll get. More important is that the internet will be used to enable, the same way as in the digital world that we're not using technically the internet. We're using the web, we're using the apps. The same way we'll be creating, enabling a logistics web, and that's where most of the people, the companies, and so on, users will be playing. So to start, my friend Russ Meller from Arkansas came up with some titles just to give a hint as to what the physical internet would be. So we say think about an open market for goods transportation, eBay style. It will handle only black box modular container, the same way that the internet only deals with data packets. It will be talking about open and shared transportation and distribution networks. We're going to talk about the vast community of users, in fact, worldwide community of users. We're going to certify the suppliers, and we'll be rating them through their performance so that we can keep on going improving. And we'll be continuously tracking and monitoring what's happening on the physical internet. So that's one small picture, but gives you a beginning of a hint of where we're going. Now, before I jump in, I just want to position it a little bit. We've got the digital internet that deals with digital information packets, and we work with the World Wide Web and the apps and so on. What we're proposing is a physical internet where we're going to talk about smart physical objects that are going to be encapsulated, and we're going to play at the logistics web level. In between, there's the Internet of Things that tries to connect objects to the internet so that the objects can talk to each other and we can talk to objects. So we're going to exploit that stuff. On the energy side, we talk more and more about the smart grid, which is basically an energy internet, and now we're talking energy packets. So this notion is crisscrossing, so the interconnection is spreading all across the world. We're giving a small contribution. So let's jump into it now. We're going to go and try to help you see what this physical internet is going to be. So first, we're going to encapsulate objects in containers, not just the big containers we see on big ships, okay? We're going to have big containers from huge site to small site. They're going to be modular, they're going to be smart, traceable, routable. We're going to be able to seal them. We're going to be able to dismantle them easily. They're going to be reusable, recyclable. They're going to be light, made of green materials, and so on. Okay, so the idea is we're designing it for sustainability and efficiency. The sizes we're talking about range from the cargo container size all the way to a pallet size and down to small box size, okay? And everything Lego style. So we show measures like 2.4 meters, 1.2 meters, 0.6 meters, and so on and so forth, always modular. And they have notions like they're going to be easy to handle, store, transport, load, unload, panel, snap, interlock, construct, dismantle, compose, and decompose. Compose, I show an example here. You put several containers, you snap them together, and now they become a single container. So once we deal with only containers, then we can transform all the basics that we're used to, conveyors, forklifts, racking system, so that they exploit this ease, the way that we're going to deal only with such containers. We also have to climb to another level in the facilities, the logistics facilities, the warehouses, the distribution centers, the factories of this world have to be adjusted so now they capture the potential. The idea is that we want seamless, fast, cheap, reliable movement through those hubs and definitely not for the goods to stay there hours and days before they can get out. So, and we have to think that we're going to use the same framework at all scales, within a factory, within a plant, all the way to within a city, within a state, all across the world, using always the same system. Now, that was the mechanics of it, let's put it this way. Now, let's switch to what it will enable. So I talked about the logistics web. For you to better understand what this logistics web is all about, I mentioned five verbs at the beginning. It was moving objects, storing objects, realizing objects, supplying objects, and using objects. Okay? So for each of them, we'll talk about the constituent of this logistics web. So let's start with a mobility web. Mobility web is about moving the objects, okay? Making sure that we go from point A to point B. I give an example from Quebec City to Los Angeles. If we go from Quebec to Los Angeles, we have a trailer to move from one to the other. Right now, we'll ask a driver to drive all the way. It's going to take that driver 120 hours to get there. And then round trip, at least 240 hours. Now, in the internet, that's not the way we would do it. So what we would have is a first driver drive a few hours, bring it to Montreal, and then in Montreal, there would be a switch. The driver would go back to Quebec City with a new trailer, and the trailer would go with another one to the next few hours and keep on going like that. So all the drivers would be going back home every day, and our trailers would get to Los Angeles twice as fast because they don't have to sleep and eat. Okay? So huge difference. Now, if I took a full trailer, now if I take a trailer that has many containers on it, so it would start in the lower left here, and then for a while go from hub to hub, and some containers would be diverted, some others would join. At one point, some would go on the train, some would go on boats, and finally each one would get to their final destination. This looks science fiction-like, okay? But basically, we've already simulated what it would impact in France with the main retailers as well as their 100 top suppliers. What is happening right now is like what we see on the left side, okay? It's a big spaghetti, and everybody does its own show by itself, okay? Then what we propose is use a network of hubs, open hubs, and then have all the mobility through those hubs. And it changes completely the full structure. More important, we just with this small change, using the same infrastructure, we're already at 26% cost saving and 3 times less greenhouse gas emission. Now, let's talk about distribution. The idea here is storing the products, okay? Just in the US, there are 535,000 distribution centers. Most companies use a single distribution centers or a few. Imagine that now you could store your products in any of those distribution centers for the same price as you would do it right now using your own stuff. Since we're putting everything in those generic containers, we can now begin to think about such things. On the production side, the same idea. Now we have a factory that makes and assembles the stuff. We could have assembly exploiting a network of open assembly centers where we assemble near point of use as efficiently as possible. And we can push even further where we could make the products themselves in many certified suppliers that are open for business. Huge transformation. On the supply side, at the end we end up with myriads of certified suppliers, open global access, standardized contracts, open monitoring, supplier ratings. So it changed completely the pictures of supply chain as we have it right now. From a using perspective, right now let me give you one example. We've got manufacturers that feed retailers and rentals, and those feed a number of clients that are not connected. What we want is to interconnect these people. So make sure that they can exchange easily between them. Now, all of this, okay, will require a lot of innovation. There's technological innovation, there's infrastructure innovation, there's business model innovation, and there's cultural innovation that's going to be needed. So as a conclusion, what we're trying to do is tackle the logistics sustainability grand challenge. Okay? Making sure we move toward efficiency and sustainability, change the way it's going from now. I want to make sure that you understand this is not utopia. We've got many companies trying to work this up and make it happen. But it's not going to happen like a big bang in one shot. It's going to be, we're going to have to start by using the infrastructure, current assets, and then through innovation, we'll get more and more exciting toward a big physical internet. This is going to be an open innovation endeavor. They're going to be needing thousands of companies, thousands of people that will have to be invested to make this happen all across the world. I hope you can help getting us toward that vision, moving that idea from just an idea to something that will have impact in the future. Thank you very much.